A very good evening to all. This is Dr. P. Pungadi, Associate Professor from SNS College of Technology. In this video, we are going to discuss the basic operational concept under the computer organization and architecture subject. Okay. Before we are proceeding to the basic operational concept, first we will have a recap on the previous topic. In previous topic, we have discussed as the functional units. There are 5 types of functional units which is available in the computer: input unit, output unit, memory unit, then arithmetic and logical unit, control unit. Each unit is responsible for its own operations. In this we will discuss the operations. Okay. Yes, first we will proceed with the introduction part. In this we will discuss about the inner working of a computer. First we will have the instruction processing, how the instructions are processed and the data is moved. And the next one is the foundational knowledge. This will be used to provide the understanding for the more complex computer systems. And the next one is the design efficiency. This is crucial for developing a efficient and hardware solutions. And these are all the fundamental functional unit. Processor, that is central processing unit. This will be used to execute the instructions and perform the operations. Okay. The memory already we have discussed the 2 types of memory, RAM and ROM. Here this will be used to store program and data for the quick access. Then the next one is input output. This input output, this will be used to get the input and present the output in the some other devices. It may be some external devices. During that time, this will be responsible to manage the interfaces. The next one is the system bus. This system bus, it is the used to interconnect the links of all the major components in the computer. Then the instruction cycle, this it will use the 3 stages: fetch, decode, execute. First it will fetch the instruction from the memory and it will be done a process through the CPU and it perform the operation through the CPU, that is execute, and use the write back method to store back to memory on or register. Then first one is we will discuss the data flow, how the data is transferred from one device, one component to another. First it will use the program counter. Program counter is responsible to hold the instruction. If when we pass that instruction to the next stage in, that is instruction register, it is responsible to get the next data which is to be given to the instruction register. Then after fetching the instruction, it will perform the decoding. Then it will be sent to the memory address register. This memory address registers, it will hold the memory address for read and write operation. After memory address register, it will be sent to the memory data register. This will act as a data buffer for memory read and write operations. Then the next one will be the general purpose register. This general purpose register, this is used to store the operands and the results during the execution. Memory operations and the addressing. The read operations, the data transferred from memory to the MDR, that is memory data register. Then memory locations, it will be specified in the MAR. This will be done during the read operation. Write operation, it will read data from MDR, then store it in the memory. Then memory location, it will be specified by the MAR. addressing each memory word has a unique binary location. Then the CPU, it will use the MAR to select the memory locations. Then the bus structure, communication pathway, it will use the address bus, data bus, control bus, and the parallel transmissions. Address bus is the, this is used to send the data from memory to and the IO devices. Data bus, which is used to carry the data between the components. And the control bus, this will be used to give the control signals like a read or write commands. And the parallel transmission, this will be used to enable the faster and more efficient data transfer. Then building the final conclusion, this will be used to execute the explain the program mechanisms. Then it will use the appropriate CPU, memory, and the IO via buses, and design and optimize the future computer systems, and establishing a strong foundation for advanced architecture. Your textbook. Thank you.